We get into the next two problems, I want to talk about how we would write an expression for an angle's complement, an expression for an angle's supplement. That's really important. If we don't know what the angle is, then we're going to assume we're going to just call it x. So if our angle is x, we don't know it, then the complement to this angle would be the rest that would add to 90. So if we were to take 90 and subtract x, that would be the complement of the angle that we don't know. The supplement to the same angle, any unknown angle, is to take 180 degrees and subtract that angle. So in the next two problems, we're going to be using these expressions to represent the supplement and to represent the complement. It just depends on what they say for the rest of how you set up the problem. So I'm going to go to those problems and show you what I mean. Here it says the measure of one angle is 3 times the measure of its complement. Find the measure of each angle. So we do not know the measure of the angle. The measure of one angle, that's x. It says is where you write equals. 3 times, so 3 times its complement. Complement to it is 90 minus x. So this is the equation that we're going to solve, and we need to then find each angle measure. So to solve this, I'm going to distribute the 3 here, and so it's going to be x equals 3 times 90 is 270, and then 3 times negative x is negative 3x. Then we're going to add 3x to get our x's on the same side, so adding 3x to both sides is going to give us 4x equals 270. And then dividing by 4 to get x alone gives me that x would end up being 67.5. So that is the one angle that they're referring to right there. So we have 67.5 degree angle, and then we have the complement to that, which is 90 minus this. 90 minus 67.5 is 22.5 degrees. So there is our pair of angles. So they said find each angle. The next one is talking about, it says the measure of one angle is 38 less than the measure of its supplement. So remember that where it says supplement, that's 180 minus x, versus where it had said complement, again, 90 minus x anytime you see that. So here, when they say 38 less, that means to subtract 38 from whatever they said next. So we need to take our supplement, and then we need to subtract from this 38 degrees. And that, it said, is here, so this is equal to the angle, which we don't know what the angle is. So here's our equation. Unknown angle equals the supplement to that angle less 38 degrees, so minus that 38 after your supplement. And so we're going to solve this. So we don't really need these parentheses here because I didn't have to distribute anything in this problem, so I'm just copying right now. And then 180 minus 38, just combining our like terms here, 142 minus x, and then x equals over here, and then we're going to add x to each side to get our x's to the same side, which will be 2x equals 142, and divide by 2, and we'll see that x is 71. So one of our angles is 71, and then 180 minus 71 gives you 109 for the other angle because these were supplementary angles. So here is kind of how you read a diagram summary, things you can assume and things you can't assume. So there are some things that you can conclude from a diagram and some things that you cannot. You can conclude in this picture, so we're talking about this over here, this little image. In this image, they didn't draw a plane, but you can assume that all the points shown here are coplanar because they're just, all sort of connecting. There's no 3D aspect to this image, no dotted lines or anything like that. Points A, B, and C, you can see that they are all along this line. So points A, B, and C are collinear. And B is between A and C. Not necessarily in the middle, but somewhere in between them. Line AC, ray BD, and ray BE intersect at point B. Angle DBE, so let's find that, that's here, that one, and angle EBC are adjacent angles. And angle ABC is a straight angle. And point E lies in the interior of angle DBC. Find DBC, see how E is in between, inside of that angle there. Things that you cannot assume in this picture. There are no right angle markings. You cannot assume that any lines are perpendicular or any angles are right angles. You also cannot conclude that these two angles over here are congruent. Nobody told you that they are congruent or that BE is a bisector or anything like that. You also don't know if the length of AB is equal to the length of BC. There are no markings to show this. So let's see if I've covered everything in this little summary down here. In the diagram above, cannot conclude that AB and BC are congruent. Yep, said that. Cannot conclude that DBE is congruent to EBC because there's no markings to represent that. And you can't conclude that ABD is a right angle even though it might look like it. The information has to be indicated like it is in this picture for you to make those assumptions. So see how in this picture AB is marked congruent to BC with this little tick mark. Angle ABD is marked as a right angle with this right angle box. Angle DBE and angle EBC have matching arcs, so they are matching, they're congruent to each other. So you'd have to have these markings to make those assumptions. The picture at the top did not have any of those markings, so you cannot make those assumptions.